Thank you for joining us. I'm really excited to jump into this session. And we have here Dirk Standaert. And Dirk, I'd like to welcome you.
Happy to be here, Alex.
So, Dirk, tell us a little bit about your background and also what you're working on right now.
Well, by education, I'm an engineer in electronics and telecom. Worked in IT for more than 15 years, approximately. Also in blockchain technologies for multiple years. Um, my main business currently is still in cultured meat, but around the same time when I started thinking about cultured meat many years ago, I also had another idea, which was around molecular beer. Back then, I froze the idea, and after time went by, I came into a position where I could maybe again open that little drawer and give it some attention, and so I did. And I went back to the idea of recreating beer on a molecular level. That means we start from water, ethanol, and flavor compounds. We mix it together and we recreate any kind of beer that you can imagine. And a little while ago, we started doing a feasibility study around this because the idea was quite insane at the moment. I collaborated with Professor Kevin Verstrepen, who has an extended background in beer science and technology at KU Leuven in Belgium. He also published a book about Belgian beers on a molecular level. And when I found out about the book, I told him, like, okay, whatever findings you now put in the book, like the analysis of the beers on a molecular level, why don't we use that to re-engineer beer with just mixing compounds together? So we did, and the first results were quite astonishing, and we decided to continue the collaboration since then.
Awesome. And so, I, I do want to kind of ask, when we hear molecular beer, is that the process that you just described, or is molecular beer, inclusive of something else as well?
No, it's like literally starting with a container of water, some ethanol that you can choose how much you want in there. So the final machine will have a little slider that will be that will allow you to just change the alcohol content. And then you have some flavor compounds and cartridges inside of the machine. And you can also personalize the taste of the beer. So you could say, okay, I like a triple, for example, but maybe not too strong, but I really like it very bitter. It's no problem. You just adjust the slider, and there you go.
Well, that's super exciting, and I think a lot of people might have the question here now. What does this have to do with space? And maybe I should ask you the question: why is it important that we should have beer in space?
Well, first of all, I guess we would start with non-alcoholic beers, and that already makes it also quite easy when we are thinking about shipping components to space. Right, we can forget about the ethanol, and when we imagine colonizing other planets, I assume we will also start with those planets where we can find water, so we don't have to worry about shipping water either. So the only thing we need to be shipping are the flavor compounds. And the flavor compounds in the mix are a tiny amount of the total volume. So it makes absolute sense to ship only that, like in a 10 by 10 by 10, we can probably fit maybe 100 beers, right? Or more. While that would take up a lot of space if you would just consider shipping, the traditional bottles or kegs or whatever.
And so when you already mentioned that you could kind of dial down or completely take out the alcohol. When we're thinking about space applications, having kind of those familiar foods in space is very important. So what better than sharing a beer with colleagues, whether it has
Hmm.
alcohol or not. But I want to ask you, would it be possible to also add different types of kind of nutritional elements, like let's say a beer with For example, even vitamin C or maybe more protein or something like that. Things that might be important in space.
Absolutely, absolutely. And well, first of all, when we're talking about non-alcoholic beers, the advantage of the molecular um, production process is mainly that it's a lot easier and a lot cheaper to make non-alcoholic beers in with our technology compared to the traditional brewing process, because normally first a beer with alcohol is produced and then the alcohol is removed, right? So it's an extra step. It's also an expensive step. And then again, you might not have a full control of the final taste. While with molecular mixing, you completely control the end result, and the production process is a lot cheaper. So that's having said, we can add, of course, anything to the mix, right? So we can add minerals, we can add vitamins, we can add anything that astronauts need on their voyage, and at the same time, they have a nice drink along the way.
Earlier this week I asked Mike Selden of Finless Foods that if you're imagining this world where we have a lot more space tourism, I asked him, like, can you imagine there would be a space flight and then they bring you this like meal, kind of like you have an airplane meal now, where you have cell cultured fish or even plant based fish. But it makes a lot more sense in this application. So can you imagine a world where you go up on a Blue Origin or a SpaceX, space tourism, and the options are, maybe Coke or Pepsi, or this type of molecular beer.
And yeah, by when you say molecular beer, you mean basically any type of beer you can imagine, right? Because by combining all these flavor compounds, we can make the entire spectrum of beer.
So the company is called Bar.on, and you mentioned a device, and so can you tell us a little bit about what this could look like, or what this will look like?
Well, we're currently working on two types of machines. So one for the living room, and then another one a bit bigger with even more varieties and possibilities for bars and restaurants. Um, for the consumer, so for the living room, the amount of cartridges inside the machine will be relatively limited. So um, it means that, for example, when you look at the molecular structure of the beer flavors, you end up with approximately, let's say, 80 components, more or less. Now, you don't need all these 80 components to reconstruct a really good beer, but you need quite some of them. Yeah, so it's not that you can just bring it down to only 10, for example. Yeah. But of course you cannot have 20 different cartridges, for example, in that machine, because, well, nobody likes to have that kind of complexity in a consumer appliance. So what we're doing is we're really approaching it as intelligently as we can to combine also different flavor compounds in several cartridges, so reducing the amount of cartridges inside of the machine and making it a very, let's say, easy to use appliance. And even then, we are able to limit it to quite a few, uh, not that many, and still being able to make a lot of different beer styles. So it's not an easy thing. The research behind it is quite iterative. So um, and we're still improving and keep on improving the recipes as we go along, because there's so many different parameters that we can fine tune in many different ways.
Jokingly, I want to ask how I can become a taste tester. um, but so would you say that from a technical process, a lot of the technology happens before it gets to the machine, or does still a fair amount of the technology happen in the machine? Would you say what's the kind of the balance there?
A lot happens on the scientific side. Yeah, that's really where the tough work lies. On the hardware side, I think the main challenge would be miniaturization. So at the same time, we're building a demonstrator machine, which is, I don't care what size. It's just something that we can we can put on a festival or on an event for people to see how it works. Um, but when we want to make it really small, for in the living room or in your kitchen, then of course, yeah, we need to make it as tiny as possible. And then you have the elements of cooling, carbonization, dosing, and cleaning, which are of course very important. And that of course poses some challenges.
And you mentioned that you essentially need to add water. We know that we're finding innovative ways to send water up to space, and like you mentioned, we have the opportunity to find water beyond, right? And so, is water the only input you need other than these cartridges, for example?
For non-alcoholic beers, yes. So it's just water from the tap, and you can argue that the water will influence, of course, the the taste of the beer, which is correct, right? There will be tiny differences, and if you really if you put in really bad water, then of course you will have bad beer. But mainly, if you use water from the tap, you will get already really good results.
I'm smirking a little bit because I'm imagining some sort of Mars Mars beer because we have some Mars water in there. But I
Yeah, imagine you produce beer on Mars and you export it to Earth, and sell it here.
Oh yeah. See, that's the true import. If if you're drinking a beer, you can have a multi-planetary import. It's we're laughing about it now, but just the conversations that we've had this last week, and really being able to see how things are progressing. As ridiculous as it might sound to have a Mars beer, I think that this is something that really might be there soon. And I think I might have mentioned this the last time we were speaking, but on one of the earlier calls, I believe it was Vincent Pribble from Micromeat was talking about how right now the average cost of sending a water bottle up into space is can be close to $10,000, where that price is going to drastically come down. And so these are the kinds of things where, like, imaginary or imagination focused conversations like this, I think, are super excited when we're talking about space and
Absolutely.
space
Yeah,
applications.
I
So
fully agree.
I think this is super fascinating. I think that from a timeline perspective, when are we able to maybe see more of what this might be? When is this something that somebody might be able to purchase for their kitchen?
Well, literally, the first units will be sold in 2024. But before, you will already see us here and there.
Great, yeah, and potential space applications. I know you were saying that there's this kitchen version, and then there's this more kind of industrial version. I'm imagining that if, let's say, there was an opportunity to have this type of bar-on product at the ISS, it would be kind of a renderation or like a version of the that kitchen type version. Is that correct?
Yes, correct. And
Okay,
we're actually considering already constructing something like that. So maybe
for
maybe
for
we'll
space
launch.
applications.
Yeah, maybe we're discussing whether or not we might also build an appliance that can go up to ISS.
Wow. Okay, that's cool. I imagine it wouldn't necessarily need to have that sleek look, but then again, when you're on the ISS, it's not about aesthetics as much as it is function, right? Where can the audience learn more about Bar.on?
Well, they can go to our website, and I guess you will be able to share the website online. It's www.baron.bar. We want to get the .com, but as you can imagine, that's unaffordable at the moment. They can follow us there, and yeah, you can subscribe to our newsletter, and you will be informed about our public appearances.
Excellent. Do you have any last insights or thoughts as we kind of wrap up the week in kind of space technologies and this fascinating technology?
Well, I was a few weeks ago, I was in Antwerp at the Space Expo. So if you happen to be in Antwerp, I can recommend to go and see it because it has like a full-scale replica of the Moonlander. It's quite amazing. It's it's an exhibition organized by Jurgen Ingels, a Belgian entrepreneur, and I can highly recommend it in the spirit of space exploration to go and see it.
Dirk, thank you so much, and hopefully, and you know, I'll go as far as saying that, you know, maybe we'll be able to cheers with some beer, maybe in space or maybe even on the moon in the future.
Welcome to.